So hello everyone, in this video I would like to introduce the setup of my product PYNQ SDR HAT. This project is now on CrowdSupply and you can follow this campaign in the link below. So this is a software defined radio extension for this pretty famous Xilinx PYNQ Z1 board made by Digilent. And in the package you should be able to receive everything on this side. So let's have a look at the details. First is this PYNQ SDR HAT itself. You can see this is the SDR chip. There are wires, RF wires going out, and on the back side is relatively simple. And for the connection to this PYNQ Z1 board, we have some slow speed digital IOs going through this pin headers as this pin goes. And for the high speed like differential signals, we have this HDMI interface and P mode interface to handle these differential signals. And on the baseboard you can see this position are meshed, so you can connect it together with these two short HDMI cables and these two small bridges. So let's assemble this board. First you may want to turn this baseboard off and attach this right on top of this baseboard. Okay, press it down, make sure this connectors matches each other. Then you can begin connecting these other parts. Like for these small ones, please remember that this chip should face the left and this place with no chip should face the right. You plug it into this P mode, and then also this HDMI cables. Just like use the common sense and don't have too much strains on these parts. And plug it to the end, and okay, now this is finished. And about the firmware is in this GitHub repo as all the other information. You can just go there and follow this quick start guide. Okay, you can download this pre-built images here. This is for Bluetooth SDR, and this one is for Openwifi, which is more interesting and is what I will demonstrate today. You can load that image into an SD card like this one and plug this SD card into this PYNQ Z1. Of course, don't forget to change this boot mode into SD. Okay, so now you should be able to start up this board. Like if I flip the power switch, you can see that this board has started, and these two LEDs on the left are faintly turned on. It might not be easier to see on the video, but you can see these are lit, so you know the bitstream is loaded from the SD card correctly. And of course, instead of the power cable, I need a Ethernet cable to connect it to my PC to SSH into this board. For the IP addresses, as I mentioned here, the Bluetooth SDR board IP will be 1.10 and Openwifi will be 10.122. So it's recommended to set two IP address on the host PC, and be aware that this is not the board IP address because these two can't have the same IP address. So you set it to something similar but different. Like on my Linux setup, I can have this set of setups First is the ordinary address I use to connect to internet, and the second and third is the two IP addresses for the two configurations. So with this one set of IP addresses, I can make sure I can connect the boards and access the internet at the same time. And don't forget the gateway for the address which you connect the internet. Okay, now let's try SSH into the board. So this will be the Openwifi, and the password is Openwifi. Here we go. And see, this is all built by the Openwifi project, which is this one. And you should be able to find all related information here. I'm not such a Wi-Fi expert, so I won't go into the details of this. If you are interested, there's a lot of things to do with it. Okay, so the first thing to do is to run this tune.sh and then check the D message. You should be able to see that the RX tuning and TX tuning are correctly finished, which means this eye diagram scan is okay and a optimum signal integrity is chosen. So if like one of these connectors are not so well connected, like if I remove one, for example, you can see that this TX is failed because of this hardware like signal integrity. Okay, so after this is successful, you can just run fosdem.sh to start the 5G Wi-Fi hotspot. Of course, you'll see I haven't connected the antenna, and I need this to let my devices to pick up this Wi-Fi signal. Like this connector has a hole inside, and the antenna I'm using right now have a needle inside, so I don't need to do anything extra. But for a standard Wi-Fi antenna, it is called reverse polarized, like SMA, so it is also a hole inside, and you need to use this small converters we prepared to let the antenna connect with each other. So okay, let's just connect these antennas. And then is to connect the Wi-Fi signal. So you can have like a mobile phone here and be closer to the antenna and like turn on the Wi-Fi. And you can see Openwifi here, it is showing up. I've connected it before, so it is saved in my network. Otherwise, it will be somewhere like here. So I'll connect to this. It's connected. You can see the logs rolling, and be careful that on some phones, the phone will just automatically drop from Wi-Fi without network access. So you may need to tweak the settings to keep the connection. Like if you go to the detail, you can see the IP address of the phone and the IP address of the router, which is this software-defined radio board. It's working as a Wi-Fi router. And I can try accessing this one for a demo web page. Just copy and paste this. It is always 13.1. So I open it and there's a demo web page. You can see and play the video to have an idea of the transmission. I'm going to drag the bar and see. Well, it's kind of slow, but it's continuous. So basically that's it. Of course, there are so many things to explore, and in the next episode I'll introduce using another interesting firmware, which is the more like popular Proto SDR firmware. So thank you for watching, and this board is now on cross supply, and you can follow this campaign in the link below. Thank you.